Welcome back, everybody. This is Miss Semino, and tonight I'm just going to be going over the quiz that we recently took on writing and balancing chemical equations. Some of you struggled with it, so my suggestion this afternoon would be that you get to the part where you see this writing here. You try to write out your own equation and balance it, and then listen to my explanation. So remember, the first thing that we do in writing an equation is we need to write the skeleton equation here. And this is going to look almost exactly like your quiz does. The only exception here is I couldn't find an arrow, so this yield, remember, means the arrow. So when you write out your chemical formula. So let's go ahead and start over here. So sodium carbonate. So sodium, okay, has a plus charge, and carbonate, CO3, has a 2 minus charge. So I'm going to need 2 sodiums, because it only has a 1 plus charge, to cancel out the 2 negative charges on the carbonate here. And if you're struggling writing this formula, I'm going to be making another video this afternoon that kind of helps review how to write these names quickly. So the next thing I have here is calcium hydroxide. So calcium has a 2 plus charge, hydroxide has a 1 minus charge, so I'm going to need 2 hydroxides to equal the charges in the calcium here. So this is going to be Ca, OH, and then parentheses 2. Remember, I need the parentheses to say that I have got 2 of them. Okay, and then yield symbol here. Now sodium hydroxide over here. So sodium only has a 1 plus charge. Hydroxide has only a 1 minus charge, so that is the formula unit for that. Then plus calcium carbonate. Again, we said calcium has a 2 plus charge, carbonate has a 2 plus charge, so it's just going to be CaCO3. Now we have the skeleton equation written. Now we need to go ahead and balance our chemical equation here. So you can write these down here at the bottom, NaCO, and H. I might just do this one on the fly because it's not a bad one. So on this side I've got 2 sodiums and 1 sodium. On the reactant, on the product side here, so I'm going to put a 2 in the front. Notice I had 2 sodiums, I needed 2 on the product side. Now that's also going to give me 2 hydroxides. Let's see if that's okay up here. Yeah, because we had this 2 subscript here. Let's continue. I have 1 carbonate ion, and remember you want to try to balance the carbonate ions as 1 unit. I have 1 carbonate ion down here, so that's looking good on both sides of the equation. And then I have 1 calcium and 1 calcium, so we are good. So we have 2 sodiums, we have, and I should have written these as the polyatomic ions here. But basically the equation's balanced. I'll do it a little more organized on the next example. It's about 5 o'clock in the morning. Okay, so another problem that some students were having is, well, when do I make it an ion? When do I just leave it as the elemental form? Well, we're looking here at phosphorus oxide, and I don't see like any, it doesn't tell me the phosphorus or the oxygen has a charge of anything. And especially when I come and I look at phosphorus pentaoxide, notice it has the prefix here. So I definitely know that I'm working with a molecular compound, so I wouldn't be having ions in the beginning. Remember, their molecular compounds are going to be sharing electrons, so they do not have those electrical charges to it. So this one, phosphorus, is a P, okay, plus oxygen. Remember, oxygen's diatomic, so it needs to be O2. And then it's going to yield phosphorus pentaoxide, so PO5 is how we'd say that one. Now let's go ahead and balance it. I have 1 phosphorus, 1 phosphorus. This is looking good. But now I've got 2 oxygens. Remember, we want to balance the oxygens last. And 5 oxygens. Ooh, no me gusta. What's the lowest common denominator between 2 and 5? 10 is what I'm thinking. So I'm going to have to put a 5 here. So now that's going to give me 10 oxygens on the reactant side. I'm also going to have to put a 2 here to make 10 oxygens on the product side. But now this gives me 2 phosphorus, so I'm going to have to put a 2 in the front over here to make sure that it's balanced. So on the reactant side I have 2 phosphorus, beautiful. On the reactant side 10 oxygens, and on the product side 10 oxygens. So this is our balanced equation. Okay, here we have an aluminum sulfate plus a calcium hydroxide yields aluminum hydroxide and calcium sulfate. So I am hoping right away, we just did that lesson on types of reactions. You're like, oh, double replacement for different things. Okay, but that's not what this video is about. So let's go ahead and write this chemical formula for this. So aluminum has a charge of 3 plus, sulfate has a charge of 2 minus, and so if you remember our quick like little changing rule, I'm going to give it aluminum 2 because sulfate has a 2 minus charge, and sulfate is going to be SO4, and I'm going to need 3 of them. Just with that crisscross rule. I don't know if you guys remember that crisscross rule we did. Okay, now we've got calcium hydroxide. Remember, calcium's got a 2 plus charge, and hydroxide only has a 1 minus charge, so I'm going to need 2 of those to make it balance. And then my yield symbol here, aluminum hydroxide. Aluminum has a 3 plus charge. Hydroxide only has a 1 minus charge, so I'm going to need 3 of them to balance out. And then we've got calcium sulfate. And so these actually balance out lovely because calcium has a 2 plus charge, sulfate has a 2 minus charge, so that's how you'd write the chemical formula for that one. Okay, so let's go ahead and balance these out. And look at the way that I'm going to write this one. So I'm going to take aluminum, I'm going to take sulfate as a whole ion, I'm going to take calcium, and then I'm going to take hydroxide. And so this is kind of like for my reactant side over here, and then for my product side I'll do the same thing. Al, SO4, calcium, and then my hydroxide ion. So right now on the reactant side over here I have 2 aluminums, and I have 3 sulfates, I have 1 calcium, and 2 hydroxides. And it's kind of just easier if we take the polyatomic ions as themselves when we're balancing an equation, because they normally don't separate unless you're dealing with water. Okay, then on the on the products side down here, we have 1 aluminum, I have 3 hydroxides, I've got 1 calcium and 1 sulfate. Okay, so let's just make sure those are working out. Okay, so the first thing that I'm going to want to do is to get there to be, let's see, 2 aluminums on both sides. So the way that I'm going to do that is I'm going to put a 2 in the front over here. Now, though, that gave me 2 aluminums on my product side, which is lovely, but now it also just gave me 6 hydroxides. So notice that I change it as I go along. I keep the tally as I add a coefficient. I want to change the tally right away. So now the next thing to look at is sulfate here. I've got 3 sulfates on the reactant side, but only 1 on the product side, so let me go ahead and add a 3 here. Now this just gave me 3 calciums as well as 3 sulfates. That's good. That's looking like it's balanced out. Now let's look at calcium up here. Calcium, I only have 1 on the reactants and 3 on the product side, so I'm going to put a 3 in the front. Now that did give me 3 calciums, but that also just gave me 6 hydroxides, but notice how that kind of fixed our problem that we had down here. So now I've got 2 aluminums on both sides, 3 sulfates on both sides, 3 calciums on both sides, and 6 hydroxides on both sides, so I am balanced. So I hope you can kind of read this after all of my scribble. We have our 1 aluminum sulfate, 3 calcium hydroxides, yields 2 aluminum hydroxides, and 3 calcium sulfates. So these are the coefficients that you're looking for. Okay, everybody, so this one is a little trickier. So we've got Mercury II hydroxide. So if Mercury has a 2 plus charge, we're going to need 2 hydroxides to balance that out. Then plus phosphoric acid. So I don't have the prefix hydro in the front here, so it's just going to be my phosphate ion, PO4, and it has a charge of 3 minus. So since it has a charge of 3 minus, I'm going to need 3 hydrogens with positive charges to balance those out. Yields Mercury II phosphate. So again, mercury has a 2 plus charge. Phosphate has a 3 minus charge, so I got to do that crisscross, that kind of switcheroo thing. Okay, and then so phosphate, PO4, and I need 2 of them because mercury has a 2 plus charge, and then water. Good. So let's go ahead and try to balance these out now. So I know I just said a second ago I'm always going to use polyatomic ions, but I also said if there was water, we need to list out the elements that are being used. So we're going to have mercury, we're going to have oxygen, we're going to have hydrogen, and then I am going to leave this phosphate ion altogether, PO4. So that's what's going to be on the reactant side. This is what's going to be on the product side. Okay, so on the reactant side I have 1 mercury, right now I have 2 oxygens, okay? I'm not including the oxygens over here in the phosphate. I have 2 hydrogens over here, and then I have 3 here, so that's 5 hydrogens in all. And then like I said, I have 1 phosphate polyatomic ion. Now on the product side, we have 3 mercuries, oops, sorry about that. We have 3 mercuries. We have 2 phosphate polyatomic ions, and then I have 2 hydrogens and only 1 oxygen. Okay, so remember we want to try to leave the hydrogens and oxygens for last to balance. So I'm noticing that on the reactant side I only have 3 mercuries. On the product side I only have 1 on the reactants, but I have 3 on the product side. So I'm going to use a coefficient of 3 up front here. So that's good. So now that gave me 3 mercuries, but now that also did change my number of hydrogens and oxygens. So I'm going to go 3 times 2 here, and I'm going to have now 6 oxygens, and now I also have 6 hydrogens from over here, but I also have these 3 over here that I have to worry about. So I'm going to change this to 9. Okay, so now I still want to leave oxygen and hydrogen for last. And so what I'm going to need to do is to now balance my phosphate ions. So again, I have 1 phosphate ion on the reactants, 2 on the products. So I'm going to use a 2 coefficient here to give myself 2 phosphates. So now it's 2 phosphates. But now that also did just change my number of hydrogens. So now I have 6 from here. Let me get the little 6. So 2 times 3 is 6. 3 times 2 is 6. So now I have a total of 12 hydrogens. Okay, so now I said let's leave the oxygens and hydrogens for last. The thing that I'm looking at right away is I only have 1 oxygen and 6 oxygens, so I'm going to need to get 6 oxygens on the reactant side. So in order to do that, I'm going to have to put a 6 out front. So now that gave me 6 oxygens, but now it also gave me 12 hydrogens. Oh, and bam, it balances. So look, we've got 3 mercuries, 6 oxygens, 12 hydrogens, and 2 phosphate polyatomic ions. Yes, we're balanced. So for time's sake, I'm just going to go ahead and write out the skeleton equation. The reason I chose this one is I really want you guys to see what I do with hydrogen. Remember, hydrogen and 7 others are diatomic molecules, so you need to make sure that you include 2 of them. So notice how I wrote it as H2 over here. So let's go ahead and try to balance this one. It looks like I have 1 sodium on this side, 1 sodium on this side. That looks good. But if I count, I've got 3 hydrogens, 1, and then 2, 3. And so that's not good because I have 2 on the reactant side. So I'm going to need something that's going to help me balance that out. So this one is a little... Sorry, that was my son asking for potato chips. So when we look at this, you guys, this hydrogen is off by itself, so this whole like finding the lowest common denominator thing isn't going to work so well. So what I'm going to do is I'm just going to start kind of messing around and playing around. So 2 is always a good one. So what happens if I put a 2 here? That gives me 4 hydrogens and 2 oxygens. But since it gave me 2 oxygens now, I'm going to need to put a 2 over the front here so I can get 2 oxygens. But now, what did that do? That gave me 2 sodium, so I'm going to put a 2 out front here. And so when I look at the balanced equation, I've got 2 sodiums on each side. I have 4 hydrogens, so I've got 2 hydrogens from here, 2 hydrogens from here, and 2 oxygens, so we're balanced. And finally, this last one that we have here, I chose because it's got the 2 acids involved in it, so I know we were having some trouble writing acids. So calcium chloride is just going to be CaCl2 plus nitric acid. So this is going to be our nitrate ion, NO3 with the 1 minus charge. And since it only has a 1 minus charge, I only need 1 hydrogen to cancel it out. Is going to yield calcium nitrate. Calcium has a 2 plus charge, nitrate only has a 1 minus charge, so we're going to need 2 of these to balance them out. Plus hydrochloric acid. So notice it's got the the prefix here of hydro, so you know you're just talking about the simple chloride element here. So the formula for this one is going to be HCl. So I go ahead and I just kind of write my bookkeeping system here. So it looks like I've got 1 calcium on the reactant side. I have 2 chlorines on the reactant side, 1 hydrogen, and then notice I wrote my nitrate as a polyatomic ion. Now on the product side, I also have 1 calcium, I only have 1 chlorine, only 1 hydrogen, and then I have 2 nitrate ions. So as always, leave hydrogen for the last, try to balance everything else out. So calcium looks good, 1 and 1. Now chlorine is 2 and 1, so this is not good. So I'm going to need to put a 2 out in the front here. And so now this gives me 2 chlorines, which is good, but now it also changes my number of hydrogens. So my chlorines are balanced, but my hydrogens are not. We're going to come back to the hydrogens at the end. Now let's look at our nitrate ions. I've got 1 and 2, so I'm going to go ahead and put the 2 coefficient out in front of this. And let's see what this does. This does give me now 2 nitrate ions, but it also gave me 2 hydrogen ions. And chabow, we are balanced all the way down. So you guys, I hope this video helps. If you have more questions, please see me before or after school. Bye.